Alright, so this is the last part of the foldable. This is the altitudes, okay? So for the altitude is the height of the triangle, okay? So you go from vertex straight down at 90, alright? So the altitude is the blank segment from a vertex to the blank side or the line that contains the opposite side, okay? It's the perpendicular. And what does perpendicular mean? 90 degrees. It's the perpendicular segment from a vertex to the opposite side or the line that contains the opposite side. Now, why do we have or the line that contains the opposite side? Remember, we talked about in class, altitudes can go outside the triangles. It depends on the kind of triangle you have. So the orthocenter is the point at which the lines containing the three altitudes intersect. So that's the point of concurrency for the altitudes. Okay, it's the orthocenter. So let's draw the altitudes in these different types of triangles. The first one that we have is an acute triangle. Okay, in the acute triangle, you've got three altitudes. We always have three of everything. So I'm going to draw my line from vertex straight down at 90. No midpoint involved here. Nothing to do with the midpoint. Vertex 90. Does not bisect the angle. Vertex 90. That's it. Here, I'm going to go straight down this way. That's not quite accurate. It probably should be more over here. That's the altitude from this vertex to this side. And then if I want to draw the altitude from this vertex to this side, it would look kind of like this. So I've got three altitudes. Those are the three heights of the acute triangle. In an acute triangle, all of the altitudes are inside the triangle. So your orthocenter is this one right here. It's where they intersect. That's your orthocenter. Remember, orthocenter, not orthodontist. Haha, funny, right? So that's orthocenter. Now let's look at the right triangle. So the three altitudes for acute are inside. Let's look at the right triangle. When we've got a right triangle, this is your 90-degree angle, okay? This is already an altitude because the definition of altitude is it's from the vertex to the opposite side at a 90-degree angle, right? Well, this side fulfills that condition. That is already an altitude. By the same token, vertex to opposite side at 90, this is also an altitude. So in a right triangle, two of your altitudes are actually sides. And then your third altitude is the one that we've been using to create similar triangles in geometric mean, and that's this one, the one that comes from the right angle. So in a right triangle, two of the altitudes are actually sides. So the three altitudes will actually intersect right there. That's your orthocenter, the corner of the right angle of the right triangle. So that's your orthocenter right there, okay? So now let's look at the obtuse triangle. This is the fun one. Okay, the obtuse triangle, let's draw the first altitude, the easiest one, from this one to this side, 90 degrees. That's the easiest one to draw, okay? Now I want to draw the altitude from here to here. And I'm going to use a different color so you can see this. I'm going to rotate my paper here so that this is the bottom of the triangle and I want to go from here to the vertex at 90. Well, there's no way for me to go from here to this side at a 90-degree angle inside the triangle. There's no way. A 90-degree angle would be here. So you know that line up here that says it has to be perpendicular to the opposite side or the line that contains that side? Here's the line that contains that side. There's your altitude. If I wanted to know how tall the triangle was from this side to that vertex, straight up and down off the ground, I have to go outside the triangle to create that right angle. You can't draw it inside. None of these create a right angle. So let's check out this one. Let's say now that this is the side that we're looking for the height for. This one right here, okay? So I'm looking for this to be the side that I want the height for. I can't draw a line from this vertex to this side at a 90-degree angle inside the triangle. It's impossible. 90 degrees would be out here. So here's the line that contains that side, and there is my altitude. So in an obtuse triangle, two of your altitudes are going to be outside the triangle. Okay? Two are going to be outside. Now they will eventually intersect, because if I were to extend them, let's say I extended the red one down here, I extended the green one here, and I extended the pink one here, there's your orthocenter. But what do you notice about your orthocenter? It is actually where? Outside the triangle. So to kind of review you again, an acute triangle, all three altitudes are inside. A right triangle, two of the sides are actually altitudes. In an obtuse triangle, two of the altitudes are actually outside the triangle. So let's go down here and look at the bottom part of the foldable. And it says, all right, in the diagram, Fi is an altitude. So right off the bat, boom, altitude, Fi. That means you go on the picture, Fi creates right angles. That's what an altitude does. It's not a midpoint. It doesn't cut the angle in half. It's just an altitude. It just creates a 90-degree angle, okay? Complete the following. The measure of angle FIG. Here's FIG. FIG. This is FIG. I'm going to draw it for you. FIG. The measure of angle FIG is what? Well, it's 90. How do I know it's 90? Because it's an altitude. That's what it means. The measure of angle FIH, that's this one. FIH, this is an H, it kind of got cut off, is also what? 90, because it's an altitude. You've got two 90-degree angles here, okay? Now it says name two right triangles in the picture. Well, that should be pretty easy. I've got right triangle FIG, this one, FIG, and I have triangle FIH, this triangle. Those are your two right triangles that are created with the altitude. The altitude will always create two right triangles. The measure of FIH is 6x plus 12. Well, what's FIH? That's this one, FIH. And that equals 6x plus 12. Well, what do you already know it's equal to? 90. So that means 6x plus 12 has to equal 90 as well. So I'm going to subtract 12 from both sides. 6x equals 78. And then I'm going to divide both sides by 6. Okay. So x equals 13. If you want to check and make sure you got the correct answer, plug the 13 in here, and you should get 90. 6 times 13 plus 12. 6 times 13 is 78, plus 12 is 90. Check. Got it. Okay? All right. So let's look at the next one. It says the measure of angle FHI is 37. FHI. Do y'all see this? This is FHI right here. If that's 37, what's HFI? HFI is this one. Well, what do you know about a triangle? What do the angles of a triangle add up to? The angles of a triangle always add up to 180, right? So you've got 37, and what do you already know this is because if it's an altitude? 90. So 37 plus 90 plus the angle you're looking for has to add up to 180 degrees, right? So what I'm going to do is I'm basically going to take 180 and I'm going to subtract off the 37, which will give me 143, and 143 minus the 90, that gives me 53. So this angle here is 53. So HFI, the measure of HFI is 53. Again, I knew the triangle added up to 180. I have two of the three angles. I subtract to find the third. The last one, it says the altitude is 16. Remember, this is your altitude. So this is 16. and IH is 30. Okay, IH is here. Well, I've got a right triangle, so I can use the Pythagorean Theorem. It wants me to find FH, which is this one. So A squared plus B squared equals C squared. So 16 squared plus 30 squared equals C squared, which is X. I'll just call this C. 16 squared is 256, 30 squared is 900. 256 plus 900 is 1,156 equals C squared. Okay. So the question is now, how do I solve for the answer? Well, I'm going to take the square root of both sides so that I could get C. Okay. So now I want to know what the square root of 1156 is. I've got 900 and 256. So you can use a calculator, which I don't have. So I'm sitting there thinking, if I go 8, 15, okay, so 16 squared is 256, 30 squared is 900, so you got 1156, and you take the square root of that. I believe you have 17. Again, I don't have my calculator up here, so let me do that. Let's see here, 1156 square root, so 17 doubled is 34. So the answer is 34. The reason I'm saying 17 is because one thing we're going to learn is Pythagorean triples, and this is actually a multiple of 8, 15, 17, an 8, 15, 17 triangle. So the square root of 1156 is 34 because 8 times 2 is 16, 15 times 2 is 30, and 17 times 2 is 34. But we haven't gotten into that yet. So anyway, that's how you do the altitude.